Hi guys, welcome to another Learn Electronics repair video. I've used this thermal camera a couple of times on recent videos and a number of you have asked me about it in the comments. So basically I wasn't sent this to review, I wasn't sent this from a company as a free sample. It was actually sent to me by a subscriber who sent me two motherboards, quite rare ones, vintage motherboards, both identical. One he wants fixing and the other one was to use as comparison, and he sent me 5 graphics cards and he said, oh, and I'll put thermal camera in for you as well, that might help you. So he sent me the thermal camera and this is what we have. So I'm not going to do a review as such of this. What I am going to do is have a look to see how useful this actually is as a diagnostic tool, as a repair tool basically. So we'll have a look at a few examples of motherboards and graphics cards and things and see how much use it is. I will say so far I've used it twice and both times it did give me some useful information. So I will link both those videos to this one, of course. So this is the camera. It comes with a USB power pack and a little instruction book which I can take out. But basically it's quite simple, and I'll tell you now. You can view the temperature on the actual screen. This has a screen on the back of it, so you can view on here. You can take snapshots using the trigger. It has an SD card in it, and then you can connect it to your PC and it comes up rather like a mobile phone would, or a zip drive with a folder, and you can view the snapshots and save them onto your PC. You can't watch the live video on your PC via the USB lead, which I thought was a bit of a shame, but that's probably only useful to people like myself who are making YouTube videos. It would just make it easier, I think, while making the video if I can capture on the screen. So I'm having to hold this so you can see it. And so far I've not done a very good job of keeping it in shot. So let's do better today on that one. Yeah. So really that's all there is much to say about it. It has a resolution, it says, of 2 degrees. I'm not sure whether that means it can effectively detect a difference of 2 degrees minimum between 2 points, or whether it can accurately measure the temperature to 2 degrees, but it can show you in the colours that it is different, if you see what I mean. In other words, can it see differences less than 2 degrees but not tell you what the actual temperature is? Of that I'm not totally sure. The resolution of this one is 160 by 120, which seems, from what I've seen, good enough for looking at PCBs with. So that's the item. I think really though what hopefully you're more interested in is how useful is this. I can just briefly show you how to use it, but I won't go into all the ins and outs. I'll show you the model number. So it's this one, DS2P31B 3AUF. So that's the actual model. And I'm not sure what the exact price of these are. It seems to vary quite a lot. There's actually a contact detail there if you want it in Holland, who are the importer. Okay, so that's a bit of information. We can have a quick look to see how much these are, but the last time I looked it was not very conclusive because there was a huge difference in price from different sellers basically. So this is the actual item, and you can see, well, this says like 1,400 euros. I'm sure the guy who sent it to me said it was about 500, but as I looked through I could see these offered at much lower prices than that. For example, this one has them at 719. IVA is a Spanish VAT basically, which fortunately I don't actually pay. That's 21%, so it would be 21% less than that if I was to buy one from this seller. But I'm sure I've seen some sellers where they're in the 200 and something euros. Yes, this one. So this is the same device, but you can see price without VAT and with VAT. So I honestly do not know whether this is like a €195 device or a €1,500 device, or if I was to order one to the Canary Islands, I would pay the net because I don't pay the dreaded VAT. Having said that, I'll probably have to pay some postage. So make your own mind up about how much it would actually cost to buy one of these. I would certainly have to say at this sort of price, I would think it was rather a bargain. And I get no commission, by the way, so if you want to buy one, wherever you think is the best place to get it from. So now we don't know how much they cost specifically. They seem to cost as much as you want to pay, to be quite honest. Let's have a look to see how this works. So basically you just hold the power button in for a few seconds and it switches on. And it takes about 8 seconds to power up. You hear a little click, another click, and it's on. So this is the camera working. First I can put my hand in front of it, you can clearly see. You can also see where my fingerprints have been on the actual anti-static mat. If I just point it, well, it stays for quite a while. It's gradually fading away now. But if I just rest my hand on here for a couple of seconds, it clearly leaves a print. So it's fairly sensitive. I mean, there can't be that much difference in temperature between the points on the mat, and yet it's reading them. You know, I can just touch here and touch there. So that's basically how sensitive this is. I think that's the best way I can use to demonstrate the sensitivity of it. It's also quite difficult to hold in place on the overhead camera when I'm highly zoomed in like so. To actually operate it, once it's on, if you just press this a second or so, you get a menu. For me, we have an option of picture, which you can view the saved pictures in it. I think there's just a couple of pictures in there at the moment. And I think you just press the power button to view it. Yeah, so that's just one I did earlier. We won't remove it. We can go to, I think that takes it back out of it. Yeah, there's another picture. Okay, just a drink bottle with some ice in the bottom, you can see that. So, that's fairly simple to use. There are options to change the powers, to set an alarm temperature and quite a few other things. But I just left this set basically to the default. I didn't actually change anything, so it's just set to the default options. I've had it connected to the PC, and basically, as I say, it just comes up like a zip drive, and you can view the saved images, but you can't really do anything else with it. You can't use it to watch live videos, I said. But it is what it is, and it certainly seems capable of doing the job. So let's have a look at some motherboards first with it. Let's see what it tells us in a real life situation. So first I have a H110M working motherboard. We can look at that. And then I have a few motherboards with the same chipset, not exactly the same board. And we can look at those as well. They are not working. They don't start or they don't boot. And let's see if we can see any obvious difference between them. This is a Gigabyte GA-H110M motherboard S2V. It's connected to the power supply, but the power supply isn't switched on at the moment. So if we look at this with the thermal camera, we should really see, you know, basically the same ambient temperature all over it. So let's just wait till it starts up. Right. So this is our thing. I mean, the things that are very reflective, like these, you'll notice come up bright. I think they're just reflecting light, basically. You can see my fingers quite clearly. So there's our board. The battery is shining brightly. So, and that's the crystal. So yeah, everything that's reflective is kind of like showing up a little bit. Now let's turn the power supply on. Let me get this where hopefully you can actually see it better. Okay, it's a little bit dark now. I've got the overhead lighting switched off, and I think that'll help us a lot. So we can see the board. Now let's turn on the power supply. So we're now in standby. And you can see straight away that something over here there, yeah, where my finger is now glowing. Yeah, can you see it there? Something down the front maybe, let's have a quick look. Yeah, there's definitely something there now getting hot, or at least warm. I'm touching it with my finger, it's a chip that's here. You'll see it's going, I'll put the light on. So in standby, that is now glowing. Although it looks like it's very hot, it's only about 30 degrees. You can see at the top of the screen the actual temperature, yeah? Is there anything else that gets warm? Well, this is the PCH, and you can't really see much there. I'm at the front end of the board now. There's something under here. Yeah, this one. This is a little MOSFET that's getting warm. So we can basically see a few things are actually getting warm on the board with it in standby. Okay. Let's now try and start this board up. So we're powering up. And let's see what happens. I have a BIOS screen on the TV. So I'm sure you can see now a few things have come to life over here. This one is now glowing much brighter. That's the one that was faintly lit before. Yeah, and there's another one over here. This is the sound chip, I think. And there's something else down here that's lit up. Yeah, that one there. Some resistors, I think. So we can see a few things have come to life, and that's what's happening with our working motherboard. There's another one over here which is getting warm. So let's have a look now with the lighting back on and see where those things actually are. Okay, I've switched the motherboard on now for a couple of minutes. I had a phone call in the meantime which is interrupting us. So we can sort of see how this is working. We have a few voltage regulators that are lighting up. So let's see, one of them is here. One of them is up here. Yeah, this chip here. And one of them is this one here. Okay, so that gives us an idea of what happens on a good motherboard when we power it on. Now let's have a look at a few bad ones. So this is a similar motherboard, same chipset, but it takes DDR3 whereas the other one takes DDR4. I have a suitable processor in an i3 6100, so that's quite compatible with this motherboard. So let's try again. I know this is a non-working motherboard which I think doesn't start, but let's see what we find. So we'll switch the power on, and again let's have a look at the board with just the standby on. I can just check to be sure that we have standby. I'll just take the voltmeter. Okay, well we'll just check first we've got standby. So we're going to ground onto the purple wire. Yeah, we have 5 volt standby. So without switching the board on, let's have a look to see if we can see anything. Well, straight away, something down here. Yeah, this one. Ow! And that is hot. So straight away we can see we have a problem there with that glowing hot on standby. And that's powering something. That would pretty much say that whatever that is powering has a short circuit. What happens if we press the start button? Yeah, nothing. So this straight away is telling us a problem down there instantly. Okay, look around the rest of the board. This is the PCH. And that's getting a bit warm. That's getting hot. So let's have a look if we can see a short circuit on this MOSFET or voltage regulator. Just switch it off and it will obviously cool down a bit. Okay, let's have a look on the test meter to see what we can see. I have the test meter on ohms range there. So this is the thing that was getting hot. This one here. It's a MOSFET or a voltage regulator. Let's have a look at the resistances around this. So we have, well, that's not a short. That's about 71 ohms. And what's on the tab? 1.8k. So we don't see a short on this. What we do see is it's getting very hot. I've just zoomed out so we can see this a little bit more clearly now. So we know this is getting very hot. In fact, it was hot enough to burn my finger, to be honest. We know there's no shorts to ground, but I suspect it's powering both of these chips. And I suspect he's getting his power in. In fact, he must be getting power in from 5V standby because nothing else is switched on. So we'll go to 5V standby and see, does that go to this chip? This MOSFET or regulator? Yeah, it goes to there on that pin. So coming in on this side is the 5V standby. And then the output is going to be from one of the other two pins. We know it's not shorting to ground. I suspect the middle pin, because that's the biggest one, is the one that's feeding the output. It's probably supposed to be 3.3 volts, maybe 1.8. But let's have a quick look. So I'm on continuity mode. Does this chip power the SIO somewhere? We can just go across it, not there. Yeah, it does. So that's powering this. And I'm also thinking it's probably powering this. So I'll just get the little heatsink off this and let's have a look. I have the heatsink off. There are some capacitors on the actual substrate here. And I'm suspecting that from the middle pin on this MOSFET or regulator, it will probably go to one of these capacitors. If not, I can look around the capacitors underneath the chip. I'm pretty confident that supply is going to go here somewhere. I thought I would see a connection on there, but I don't. But it doesn't mean it's not going here somewhere. I'll just look around some of the capacitors in the area. Okay, I don't see a connection to any of the capacitors on here. I'm a little bit surprised. I thought it probably would do. But now I've got the heatsink off. Let's try this again. We'll go into standby again. I'll just try and position this where we can see it clearly. And let's see what happens. So standby is on. Instantly that is glowing, yeah. We can see that is getting hot. Can we see anything else? Well, the PCH is definitely getting warm. You can see that, yeah, it's getting warm. How about the SIO chip? I think again I'll have to turn off my overhead lighting so you can see this. So straight away we can see that is glowing. The SIO isn't even lighting up. And now we can see it, yeah, straight away that the PCH is also glowing. So the camera's definitely told us in this case that we have a faulty PCH. Although it's glowing, this actually is quite cold to the touch. I don't feel any heat on it from the finger. But the camera is obviously sensitive enough to actually see that as being hot, even though the power's off. Yeah, look, you see it. It's fading down now. Let's just put the power back on again. Okay. Yeah, there, you see straight away that is generating heat. In fact, it's hot. It's hot. So we know what's wrong with this just by using the camera. Okay, so that's one board diagnosed very quickly. I've just got it powered off again. What we can just also do is have a quick look to see what voltage is coming out of this. I mean, have we got like effectively a short in the regulator, which I don't actually see, but we can just effectively test. So we know the 5 volts is coming through now, there's no short there. So I don't think this is sending too much voltage out and this is glowing hot. It's just the fact that this is failed, that's where all the current's going. But we can have a quick check because this is all about exploration, yeah. So just go on here, just go back onto voltage. Okay, on the voltage range. We'll check once again, we have 5 volts. Yeah. 5 volts, and then what's on here? Yeah, 3.3. So it's regulating, it's just supplying a lot of power into here. So we know straight away this motherboard has a faulty PCH. Let's look at another one. Here is a Gigabyte board. This one's a H310M-S2H. This takes an 8th generation Intel Core I processor. I have a Pentium Gold in there at the moment. I have this one, the G-4900, but that's compatible with this board. Again, we at the moment have no power on, so we'll do the same that we did with the other one. We'll just check to see that we have the 5 volt standby. So it's now switched on. Yeah, in fact that reads slightly higher. I've got a feeling the other one was even dragging the 5 volt standby down slightly by the power it was drawing. So let's see if this one will tell us anything. We'll put the camera on. Let's have a look. Well, again, this appears to have basically the same sort of problem. We have something down here. Yeah, this inductor here. No, there's MOSFET next to it. Yeah, and that's quite hot. I mean, it's warm, it's not hot. And we have that's basically it. It's all down here on this one. Again, we're in standby, so the only thing that should be powered up is the Super I/O and the PCH. The PCH isn't particularly getting warm. Let me take the heatsink off it. Okay, I've removed the heatsink now, and yeah, that's getting hot again. And these should not get hot when there's no main power. We only have standby. So once again, this appears to have a faulty PCH, and it's causing the MOSFET. Once again, this will be going from 5 volts to 3.3 is getting hot. You see that the heat's just spreading around. I have it switched off now. So that's the second one of those that has a fault, and this is found it again. Let's try some more motherboards, and maybe ones which have different faults than these, which effectively would not power up. This is an older motherboard. It's Asus P5G41T-MLX. It's a DDR3 board with a Core 2 Duo processor. Now this one, if we power up, and I've actually put the post analyzer card in, this actually boots up to a point. It's just reset itself, you can see there, and it's powered itself back on again. And this one ends up with this error B0B0, which I'm fairly sure is something to do with the onboard graphics, because there's no GPU in here. We can try it with a GPU, but let's just have a quick look to see what that error actually means. B0B0. Well, it just says the system configuration is displayed. Really, it doesn't give you any much information, but that's what we have. I'm fairly sure this one is something to do with initializing the graphics card. Let's just try find a graphics card and put that in and see whether that gives us any different code, or it behaves differently not using the onboard graphic. I have just an Asus graphics card here. I'm not quite sure what it is. EN7600. I use this basically as a test board. I know it's a good one, so we can put that in there. It's switched off at the moment. We'll go on to the GPU. I'll just find something to prop under the edge of the board so that it will just sit okay. Right, so that's in there. I'll move it a little bit as well so we get into shot. Okay, so let's see if this does the same thing. So power on. B0, B0. I don't get any bleeps out of it, by the way. So again, I think it's stuck on the same error code, and it makes no difference from what I can see. I have nothing on the screen, there's nothing coming out of it on the monitor, and adding the external GPU didn't seem to make any difference. So let's go back onto the internal one again, and then let's see if we can see anything with our thermal camera and maybe give us some idea of where the problem is with this one. I've zoomed out a little bit as well, make it easier. I'm fairly sure with this one, I'll just check this, power's off, that if we remove the RAM, I think it actually bleeps. So we'll switch it on. Yeah, so it bleeps on RAM, so it's obviously booting up to a point, but there's something it doesn't like, and I'm pretty sure it's when it's trying to enable the graphics. So we'll put these back in again. Okay. We'll switch it back on. And now let's see if this will tell us anything helpful at all with this one. I can see straight away that these MOSFETs are getting quite hot again. So that's these ones on the board here. And they're 50 degrees, it's saying on the screen, if you can read it, more than 50 centigrade, so they're quite hot. Down here, these are the V-core basically, and they're not running particularly hot. This has an habit of doing that, so it's to pause and then come back on again. I see something else down here, but I don't think that's a problem. It's like 20, it's 30 odd degrees, it's not overly hot. Yeah, the heat is definitely coming from these two here, and these are higher than 50 centigrade, and I'm pretty sure if they're supposed to run that hot, they would have a heatsink on them normally. The other thing that's getting rather hot is well, actually not particularly, this is the PCH. This is running cool. This will be the SIO, I'm guessing, or and there's probably North Bridge and South Bridge, actually, there's two chips. But this one, I suspect, is involved with, in fact, I know this one will be involved with the communication between the RAM and the PCIe. And I'm wondering if these things here actually are powering this. If that's the case, I suspect this is probably faulty, because I don't think they should be running at such a high temperature as that we've seen on there. Let's try with a meter and see if we can figure out where this voltage rail is actually going. Well, the first thing would probably be to have a look to see what the voltage rail actually is, the voltage, you know, what it actually is. What is the voltage? So let's have a look. Probably the tab is the output. 3.3. 2.2 on there. See if we can see what's on the other pins of it. Get onto this ground. Let's just see if we can get in. It's a bit awkward for you to be able to see what I'm doing, but I'll do it this way. So this is the end pin, probably the source. That has 2.28 on it. Oh, I see. This is like a VRM. Yeah, there's a little inductor coil here as well. So that there is also on here. Yeah, that's the junction of the high side and low side MOSFET. This will be a VRM, and it's generating 2-point-something volts, which in itself seems a little bit strange. That's the 3.3 coming in. This will be ground. I'll just try and move the heatsink a little bit. That's ground going out. And this is the junction of the high side and low side, 2.28. This is now getting quite warm, so I'm pretty sure that's where it's going. But let's have a look. Well, in actual fact, this isn't quite wired up like that. First of all, this appears to be the junction between the source and the drain, and this is where we had the 2.28, and those 2 points are connected together. But if we go from here to the little coil, it doesn't go to here. In fact, this little coil, I've figured out, goes to this chip somewhere. Just move across it. Yeah, there. So that appears to be driving this little VRM, but these are for me some sort of voltage regulator, I'm pretty sure. Looking from the output, which is on here, I'm just having a look. I'll put it onto continuity mode. The bleep. I've taken the heatsink off this. I'm just wondering see if it goes to any of these, which look like capacitors on the chip itself. Doesn't appear to do. No, it doesn't appear to go there anywhere that I can see anyway. What's the resistance from here to ground? Well, it's not short. Let's go to resistance mode and let's have a look. Right, we're on resistance mode. So the resistance from the 2.8 to ground, well, it's very high. So whatever's causing these to draw so much current is not that. This is the end that goes to the 3.3. I'm pretty sure it goes to 3.3 coming in somewhere on the, yeah. I'm just going to the actual ATX connector, actually 3.3 coming in. And this should go, you would think, to ground. So let's have a look on here. What? Does it go to ground? No, it reads about 27 ohms to ground. And this pin looks a bit tarnished actually. Can you see it on there? So that's reading about 27 ohms to ground, which in itself seems to be a little bit strange. And I don't see any coil around here that would be the VRM. So I don't think it is effectively a buck regulator. I think it's some sort of regulator it's for me. Have a look around some of these capacitors in this area. I'll put it back onto continuity. Now, I don't specifically see anywhere that's going to in that area. I think to figure out what this is doing, I would have to see if I can just find a schematic for this board. Let's have a look, see if we're in luck. Well, we're in luck, guys, because I do actually have a board view for this motherboard. And these are the two MOSFETs which are getting hot. This is what I thought was a high side MOSFET. And you can see that the pin here, the drain, which is 3 volts, actually does go to the ATX, which is where I measured to, the 3 volts coming in, or 3.3 volts. So we have that. This effectively is the junction which I thought was going to drive a coil, but you can see it goes nowhere near the inductor coil. That is where I'm reading the 2.58 volts. So that brings you really to the pins on here. So this is the pin that I thought was ground, but it's not ground at all. It's VTT to the CPU. So it's a positive supply voltage that powers part of the CPU here. It also powers part of the north bridge. This is the south bridge. It goes to the south bridge on a couple of pins. And it goes to a few more places down here as well. And that's basically, and it goes to the SIO over here on one pin. But if you look, the place it powers most is this, the most pins. So it would appear that this north bridge and the CPU are the thing that's drawing the most power. So first of all, let's measure the voltage on here and see what it is. It should be about, I don't know, 1 volt, 1.2 volts, 1.5, somewhere in that region without looking it up. I'm guessing maybe about 1.2, 1.3. And this is the point where I was reading about 27 ohms. I can just check it again. So knowing the resistance to ground from here, and once we know the voltage on here, we should be able to work out the current that's flowing from here. Obviously that doesn't include current flowing into semiconductor devices once they start drawing power, once the semiconductor junctions turn on. But we can have a look. So first of all, what's the voltage on this point here? Well, here's the VTT pin, so we can check the voltage on here, and then we can just remind ourselves what the resistance was. So we'll just switch on. I have the ground connected to the motherboard. And we have, yeah, 1.205 volts, so, or 1.21. So that is about what I would expect it to be. Let me just remind myself now, what was the resistance from here to ground? It was about, well, there's probably a bit of voltage still in this, which is discharging if I just give it a moment. Yeah, about 28 ohms. So a quick calculation, the current from here, I, is V over R. And here I have, on my phone of course, a calculator. So the current, I equals V over R. I'll show you how to remember that in a minute. So the current equals voltage divided by resistance. So the voltage is 1.2, it's in volts, yeah? And the resistance is about 28. So that should be supplying about 42 milliamps, which is not a lot, and it shouldn't be getting hot, but it is getting hot. So something somewhere is drawing power from this. I mean, the wattage is current times voltage, so that times 1.2. Yeah, there's your wattage. Yeah, about 50 milliwatts. It's nothing, is it really? Okay, so let's have a look at two things. One, how you can remember Ohm's law very easily, because I always do, and I use this method. And two, let's see what's getting hot on this, and that'll probably tell us where the fault is. Quick one, how to remember Ohm's law. And I was taught this in 1982, and I've never ever forgotten it since. You put a pyramid, okay, or a triangle. V, I, R. Yeah, V-I-R. If you remember, the V has got the point on it, goes to the point of the triangle. That's the best way you can remember that. And R goes to the right. Yeah, R to the right. That looks like a little letter L, L to the left. And the V effectively is the vertical, the point, yeah. Whichever way you want to remember it, just put the V-I-R on the triangle like that. Yeah. Once you've got it, you can always remember Ohm's law. V equals I, R. Voltage equals current times resistance. Yeah. R equals V over I. Resistance equals voltage over current. Yeah. Current equals V over R. I equals V over R. Once you've got that, you'll never ever forget it. So always remember, R is to the right. Yeah. What looks like a little L is to the left. And V is at the vertex, the top, yeah, of the triangle. Okay? Say it to yourself 10 times over, you'll never forget it. And that'll come in so many times useful when you're repairing stuff. The only other one you need to know, what equals V times I. I don't know a quick way to remember that, but there you go. Okay, lesson over. Let's see what's wrong with our motherboard. Back to our motherboard. I've taken the heatsink off, and you can see actually this is kind of like burnt away, like it's been getting hot, and I suspect this is likely where the problem is. But we know it supplies that, the north bridge. We know it supplies the CPU, and we also know it supplies a south bridge down here. So we'll take this heatsink off as well, and also we know it supplies some little components down here and the SIO. We can see that from the board view. So I'm going to take the various heatsinks off, so I'm not going to run it for very long. I'm going to switch it on and see what gets hot fastest. Yeah, you'd expect the CPU to warm up a bit, to be quite honest. In fact, you'd expect everything to warm up a bit, but because it's sort of hanging on post, I don't think things will warm up very fast. Okay, let's just remove the other heatsink. We're ready to go. The thing that's shining a bit is the CPU. I mean, the power's off at the moment, but I've noticed reflective things tend to do that with this. I'm just touching here now the north bridge, which I most likely suspect is a problem with this, and the MOSFETs are just here. So you can see, if I just get the camera, yeah, you can see where they are. Okay. You can see the CPU. I can't easily see the other side of the board at the same time. But let's have a look to see if something instantly reveals itself. And I suspect it's going to be this. Okay, let's power on. Yeah, straight away, yeah. We know where the power's all going. and it's not hot at the moment, but it was definitely straight away. That's where it went. Yeah, I can just do it again, just get the light reflecting. Okay, once again, this is the north bridge here. That is a CPU. You can see these are the MOSFETs. Let's have a quick look. Yeah, you see it, and we'll just come to the other side. So this is the other one, the south bridge. Super IO is dark. That's hot. That's hot. Over 50 degrees. 36 degrees. That's the south bridge. I'm pretty confident I can see where the heat is going there. So once again, it looks like we have a faulty north bridge in this case. On the basis that gets hottest the fastest. I mean, the CPU is hardly warming up. It was, there's not much heat in there, and these are obviously providing a lot more power than they're designed to do on that circuit. So yeah, you guys let me know in the comments, but I think again we can say that's what's wrong with that one. I have another one. I've looked at this before as well, and I haven't been able to fix the problem on it. So this one, it's a TUF Z270 Mk2. Takes DDR4 memory. I've tried a number of different RAM strips in this and different combinations, but basically with this one, if you power it without the memory, it bleeps. If you power it up with the memory in, it doesn't bleep. And there's a little mem OK button in the corner here, just behind the little stand for the camera. But if you hold this in, it then flashes the memory light and goes through a whole sequence of testing different memory configurations before coming back to having no picture. So I've put the PCIe analyzer in. It's, well, the TPM, if you like, analyzer in, because on the Asus motherboards you will not get error codes out of the PCIe slots. So we put that on there, which kind of goes back to front on these, and we can now power this up, and let's see what it does. Well, it starts, and you can see it's running through the various codes, which might be kind of upside down on the camera the way I've put it. It's kind of back to front to me as well. And it stops on 0A, and the VGA light is lit up. So again, this seems to have problems accessing the graphics card. It's got onboard video, and also you can put a graphics card in. So in the past I've tried, like I did with the other one, with an external graphics card, and a good one with the onboard, and it always gets the same error. We can have a look at our little book of codes for this one. So 0A, see if it will tell us anything other than the fact we have the VGA light on. CMOS checksum calculation is done. Initializing CMOS status register. Okay. I've also previously with this one removed the BIOS chip and reprogrammed it. It made no difference. So it's not a BIOS chip problem. We just have this. Let's see if the thermal camera gives us any idea about this one. Well, we can see, I mean, there's things getting warm on here. There's something here which is actually this, which is a buck regulator core. It's only 32 degrees, and I mean, you'd expect things to warm up as the thing's been left switched on for a little while. So what else we can see? Oh, okay, there's something here getting hot. This is over 50 degrees again. Sorry, that's up to this, messing with the camera. So this has something down here over 50 degrees, which is this chip. So that is hot. Yeah, it feels hot. Anything else on here? There's a couple of things down here, but these are the VRM. Obviously this camera's upsetting that one. Yeah, one moment. The instrument camera obviously didn't like something I put this close to it. So this one, I can see, I'll move out of the way, is about 40 degrees. That's something down here. Just find out what it is. Yeah, these are V-core MOSFETs, but they're not getting as hot as that thing. That one is the one that's really getting hot on this motherboard. So let's have a look to see what that device actually is, and maybe in some way if it's related to the problem we have on this. Well, this chip as media ASM 1142, and it's kind of in the area where we have the various connectors, yeah, on the motherboard. So I'm suspecting it's something to do with USB or LAN or something like that. I mean, maybe this one's to do with the LAN sockets are here. Let's have a look at the datasheet. So ASM 1142. Let's see if we can figure out what that actually is. I couldn't really find a datasheet as such, but we can see it is a USB 3.1 host controller. Maybe this gives a little bit more information about it. There seems to be some security risk there. I won't bother to go, but that's what we appear to have, is some sort of USB controller. Now, it kind of makes sense that if this maybe has some problem with the USB 3 ports, or somebody's connected to this, some device which sends too much voltage down there, or some other problem, this might have been damaged, but I'm sure that thing should not be getting hot. So what I think I'll do with this motherboard is remove that chip and power it up without the chip fitted and see what it actually does. We can see the chip. I'll just have a look down the USB 3 connectors, just see if I actually see any bent or damaged pins in any of these, maybe. So I'm shining a torch down them, and I don't seem to have any visible problems there. Maybe it's these green ones, but it's hard to show you guys. You can perhaps see now, but they look okay down there. So let's remove that chip. Let's just take it off the board and try and power it up without it fitted, because I suspect, maybe, but it's only a suspicion, that this will power up without this chip, obviously without the USB 3. Let's see what happens. It's got to be worth a try. I have the chip cleanly off the board, so this is the actual chip. You can see there's no solder bridges between any of the pins. It came off very cleanly, and the board is looking very clean. You can see the chip there. This again is all looking very clean. I don't see any problems with solder bridges, so I think I can just power this up now and let's see what happens. I mean, I have no idea if it will work without this chip or not. I mean, it might just not complete the boot sequence, or maybe it will, but possibly we'll get at least a different error code out of it to show us we've achieved something by changing the chip. We are ready to go again. In my optimism, I've attached the DVI cable, switch the power supply on. Let's start the board and let's see what it does without that chip fitted. Well, we still have the same problem, so that is still stuck on the OA. Let's get the thermal camera again. Let's see if that's, obviously that thing isn't going to be glowing anymore. See if we can see anything else with this. You know, I was hoping that might actually have worked. Okay, what we got? Well, there's still something down here. That's the chip next to it, which is not. Yeah, 43 degrees. I've got that little green cross onto it. There we go. That's this one. That area of the board is still a little bit warm from when I desoldered anyway. These are your VRM modules. Nothing particularly hot there. I know they light up. This is the something in here. That's another little VRM there, just running a little bit warm, but it's only just 30 odd degrees, nothing strange. What do we have down here? we have something down here. I'm not quite sure what it is. It's down by the side of here. Oh yeah, there's a chip down here by the PCIe. That's a finger underneath it. That's above 50 degrees, that one. What's that thing? Well, this one is this chip, 75232G, which is an RS232 driver. So this is for a COM port, a serial port. And in fact, it's sitting right next to a serial port on the motherboard, actually. This has various supply voltages, so VDD, VCC and VSS. And we can see them marked here: supply voltage, supply voltage, supply voltage. It gives us some absolute maximum ratings here. If I scroll a little bit further down, it gives us some recommended operating ratings. So we can see we should have a plus and minus 9 volt supply and a 5 volt supply. And the pins are on 1, 20 and 10, so they're quite easy to get to. The reason I was looking at the voltages, and this is the chip that's getting hot, and this is a COM port here, serial port, says COM on it, which will be connecting to this. I'm thinking this motherboard has had something externally connected to it that's blown some components on it, or there's a problem with one of the power rails, because this chip, I'm pretty sure, will have in common some power supply which goes to the USB 3, because they're both effectively serial comms. It's just a gut feeling. So I'm going to measure the voltage supplies around here, and if they all read okay, I'm going to take this off the board as well. If that makes no difference and it won't power up, then I'll put this on one side, because I don't really expect to get into any involved repairs on this video. The whole idea of this is how useful is the thermal camera. But I do think it's worth trying. So let's have a quick look, and then if we don't get further with it, well, we can look at this on another video. But again, I'm pretty sure this would power up or stop on a different error code in the BIOS without the chip actually fitted. Let's get the test meter and let's see what voltages we have. First thing then, let's just measure the resistances on these voltage rails. So I'll just get a ground point. Okay, I'm on ground. Just make sure I'm on a good ground here. Let's see what I have. So this has quite a low resistance, actually, about 43 ohms. It's a little bit surprising that that would be so low, but fair enough. This one, well, it reads 320 ohms, and this one reads, let it just settle down a bit, quite low again. Let's get onto it. Okay. Yeah, 120 ohms, I think. I'll just see better on the screen, actually. Yeah, 120 ohms. So one of these voltage rails actually reads a little bit low on the resistance, although I don't know what it's supposed to be, but it just seems a little bit low. Let's power it up and let's see what voltages we actually get on these supply rails. So I'll just go to volts range. Okay, on volts range. Let's have a look. So we'll power our board up. It's running. Let's see what we've got. So this is the first voltage rail. I'll probably just have to use the magnifier actually. Let me see if I can get onto it. This is the first one. I'll get it under the microscope. It's going to be easier for me to do this without risking the fact I might slip. Okay, you can see it better as well now. Let's have a look. So we'll go on to get a ground. Yeah, I'm on ground. We have. Well, this one's easy to get to. And that's 5. Even without my glasses, I can basically read that. This one, minus 12. And this one would be the plus 12, I would think. This one's a little bit awkward to get down to it. Plus 12. Well, the 4.43 ohms doesn't seem so strange on the plus 12 volt rail. If I power this off, I'm sure I'll see the same if I measure from 12 volts coming in on the ATX connector actually. Let's have a look. Here's the ATX connector then, so we'll go to the 12 volts. We're going to see the same 43. Well, if we put it on volts range, we might. Sorry. Well, if we put it on ohms range, we might. If I put the meter where you can see it, we might as well. Let's see. Yeah, it's very similar. Very similar. So, I don't see any particular reason why this chip should be getting hot either. I'll take that off the board as well, and we'll have one attempt again to see if we can actually get this thing to boot or fail in a different way. And if not, we can come back to this one and we'll continue to play with the camera a little bit more on a few other things. This may be a bit tricky to do with the PCIe slot and the plastic headers here. But at the end of the day, I can always change the pin header. I can always do the same with the serial port header, to be quite honest. I think the first thing here is going to get us off the board and see if it actually fixes our problem. So again, I'll use a preheater like I've just done with the other one and the hot air. I'll take it off and then let's see what happens. It's off, not perfectly. I mean, that was a very difficult place to get to. So the serial port header basically survived, a little bit melted on the corner there. And this obviously didn't survive, it's all melted up, but it's just a pin header, that's not a problem really. And there's a little bit also of heat damage on the end of the PCIe slot, but that's the best I could do even with a preheater. Once you get the hot air in there, things are going to melt a bit. But it's off clean, there's no shorts between the pins again. So we can once more power this board up and see if it'll work without this chip, or see if it'll stop on a different error. We're ready to go. Let's see what happens. Oh, well, that falls off. That's what happens, yeah. Let's have another look to see what happens. Put the power switch back on, the right way round, it's on. Well, it powers up. And it still stops on the same code, doesn't go any further. So there's obviously some issues with this which we are not finding, or it won't boot up without the chip fitted. You know, who knows? I'm kind of like just trying a few things here. Something else getting warm on it. Again, that's this coil, this inductor, but it's not particularly hot. It's 36 degrees. We have another something down here as well, but again, whatever it is, it's not particularly hot. I'm on it now, it's like 35 degrees. So I think with this one, we can say yes, there's things that are warm. Another one here, 36 degrees. But again, that's not particularly hot. That's the one of the MOSFETs over here. Yeah, interesting. Some of the MOSFETs are running a bit hotter than other ones. You can see that on the camera quite clearly. But I think in this case, we can say that whatever is a problem with this, either we haven't fixed it, or it won't go past this point in the BIOS unless I actually replace at least maybe the USB chip. So we'll put this on one side and we'll have to class this one as a failure at the moment. Let's have a look at some GPUs instead. Here's a graphics card I've looked at before. This is one of Lewis and Alborough's. It has a couple of different problems, but one of them is that on the 3.3 volt supply coming in, which is pin 4 on the PCIe, we have about 15 ohms, and it should be several hundreds of ohms. I've looked at similar cards. This is an RX 480, and that is much lower than it should be. But because of the resistance, 15 ohms, it's on a 3.3 volt supply. Really, if you inject voltage to it, which you can inject 3.3 volts, nothing is going to get particularly hot. So it makes it very difficult to trace where that goes. I also don't have a board view either. So I can just show you now why it doesn't get hot as such. If find the calculator. Okay, so a little bit more Ohm's law. We just did it before, so you should probably know it now. So first of all, we have to find the current. I equals V over R, which is 3.3 divided by 15. So the current is 220 milliamps times the voltage, 3.3, means about 0.7 of a watt. So that should probably warm something up, but unlikely, unless it's a very small component, to get hot. Now, I do know that the 3.3 volt supply goes into the GPU in part, and it also goes in amongst other places over here. So this is a little chip U200, and somebody advised me that this is to do with the fan control, and this sometimes goes short or faulty, and you end up with about 15 ohms. And if we come to this chip, just make sure I've got a good connection on ground, yes, and we have a look, in fact you'll see we can find the 14.9 ohms. So it does come there, but that's only because the 3.3 volts comes here. I've taken this chip off and checked it out of circuit, and there was nothing wrong with it. So it's now back on there again. The low resistance was still there without it fitted. So I'm thinking now maybe with a thermal camera we can actually figure out where this low resistance is on this board. So let's give it a go. This GPU doesn't fully power up, by the way. I can just show you that. So we'll go to V core, which is on these coils, and you'll see that we don't get any V core, so the GPU doesn't get hot. Just switch this on. Okay, we've powered on, and we'll just go to V core, and that'll go into volts range. So I'll just show you that. I've just switched on. GPU's cold, yeah, there's no heat there. And we can go onto the V core. We don't have any V core. The last voltage that actually comes up is this one, which is PEX. And then the next one that should come up is this one, which is the memory controller, but it doesn't. Effectively, the power good coming out of this is going on and off. It's not effectively powering up the next one. But we have this low resistance problem. So I'm interested to see where, if anywhere, is getting warm enough to show us where that low resistance is. Because it's likely the two problems are actually related to each other. Okay, I have the camera on. Let's have a look. Well, the GPU is reflecting a lot of light, so we can't really say that is where it's going. The thing that's glowing over here, which is about 35 degrees, that's the regulator on my actual adapter. You got a lot of reflection there. Okay, so there's something here that's getting warm. That one. That is the controller which powers up the memory controller and the main VRM. And this, I'll link the previous video on this one. But this is where I'd pretty much come to that there was a problem with this chip. The fact it's getting warm and the VRM is not running makes me suspect that my original diagnosis on this one was right. Let's just turn it over and see if there's anything on the other side of the board that we can notice getting warm. Well, there's something down there, but it's only 29 degrees. I'm sorry with the overhead lighting. Makes this video a bit difficult to make, but I'm sure you can see enough to know what's happening. Again, something on this end of the board is getting warm. Here. This is actually behind the chip on the other side that I just said was getting hot. So I think with this graphics card, it's basically leading me to where I had already diagnosed by other methods, but it's doing it much quicker. I'm just back on the other side again, and you can see it there clearly. Yeah. Even though to touch, it's not necessarily hot, but that's where the heat is. Let's have a quick look what that chip is. I remember it's some sort of international rectifier one, and I'll explain what else I need to do on this repair. This then is the chip that's getting hottest, and it's not running. If you watch the video I'm going to link, you'll understand that I'd already come to the fact that this wasn't working properly, and it was to do with the enable pins. And I'd got to the point really where I said I need to order one of these to see if it's causing the problem. I found out since, because I'm learning as much as you guys are, I think, that this is actually a programmable device. And to replace it, you need to reprogram it. And I haven't yet gone and looked up or found out the ins and outs of programming these devices. But I'll call this video a success because the camera very, very quickly led me to the same place. And when you've got two things saying that's the problem, the chances are that's the problem. This is a GTX 750 Ti. It came with a batch of cards from eBay as spares or repair. I fixed one problem with this and then found that it has vertical lines on the screen, which looks like a problem with RAM chip or with the GPU. Looks like someone's tried to reflow this before now, and I put it on one side basically. Maybe memory faults, maybe I need to unsolder them all and check all the lines going back to the GPU, see if there's any broken ones or any different readings in diode mode, which would say memory controller, and if not, rebuild them, put them back on, and for that matter change the chips. So that's where we are with this one. Now this one does detect, it takes a while, and it does give a picture, but it has vertical lines on the screen because of the memory problem. So I need to keep this cool enough to run while we effectively, I want to try and see if any of the memory chips are getting warmer than any of the other ones, which might give us a clue. So this is an old AMD fan with a bit of masking tape, masculine tape we called it in the 70s, because we thought it was funny. I obviously still do think it's funny. So we'll put this on here so we can run this for a little while and keep it cool. That's connected to the chassis fan on the motherboard. So we'll switch the power on. We'll boot this up, and we may get a picture after about a minute on the screen. If we do, I'll show you. It's going to come on there. You see it? Yeah, show you sort of corruption on the screen. So that's what's wrong with this one. Now let's see if the thermal camera will show us anything up. So the first thing, we have something down here which is lighting up and it's quite warm. Check the green thing on. That is the VRM controller, which is about 40 degrees, but bear in mind that is running. Yeah, that thing, that's working. All the VRM is running, so that's going to generate some heat. But the one I just looked at, where the VRM wasn't running, was as hot as this one basically. Anything down here? Well, you can see the RAM chips. 1, 2, 3. There's a fourth one lit up. There's one there. Oh, look guys. Let me tell you. This RAM chip's running. I've just touched the RAM chip. This one's running. Okay, it's warm. This one's running. This one's running. But the other one here isn't lighting up. It's cold. So again, that's told us straight away there's a problem either with the supply to this RAM chip or with this RAM chip. So I think once again the thermal camera has actually found us the problem on this graphics card. That's a result. Yeah, I'm pleased with that. Let's look at one more. I'm picking these at random, basically off the shelf. These are things that I've looked at in the past and either got so far with a repair like that last one and didn't go further, or possibly just put them on one side, know there's a problem, thinking, oh, I'll look at that sometime. So this is a AMD 58 something or other, I think. Let me see, what is it? Yeah, this is a HD 5870. As I recall with this one, it doesn't detect or doesn't power up. So let's do the obvious first. Let's see if this has any VCore. So we'll power the PC up. I mean, the quickest way probably to test is just put your finger on the GPU. Oh, that makes a very loud noise. Okay, that has some problem with the supply. So that's not, well, it may tell us, yeah, that's this noise. There's some problem with this little speaker with the 12 volt supply or something like that. So let's go again and let's put up with the noise and let's see if the camera tells us anything. So we'll switch on. That's cold. Sorry about the noise. Okay, is that a bit better for you? Let's see if this does anything. Still cold. Okay, what's this doing? Again, that's on my little mining adapter. I'll switch the thing this way and let's have a look down it. So that's my finger on the annoying noise, yeah. So this one is not giving us any indication whatsoever, apart from the fact it's cold, so there seems to be no power supply on this. So that one, we'll have to say, is a failure. Okay guys, there we have it. I have to say, I'm highly impressed with this thing. I've never owned one. I know people swear by them, and I've always thought, yeah, but, you know, do I need one? And you know what? Actually, I think I do need one. I'll be honest with you. I can sit here all day, taking everything off my shelf of things I've put on one side, and go through the whole lot of them on video, and showing you what this is showing me. And that'd be great for a while. Then you'd all fall asleep, and I'd still be enjoying myself. So I looked at everything. Now I want to look at some more things. So I've got to say, this is something of a revelation to me. This is an eye-opener, yeah. And I got to get myself a thermal imaging camera. But I do have to say, I will mention this, and hopefully you've got this from the video I've just shown you, or subjected you to. This is a tool, yeah. This is a tool in the same way that a multimeter is a tool, that an oscilloscope is a tool, and all the other things we use in electronic repairs are tools, yeah. They're tools to do a job, and they will only do the job if you use the tool correctly to its full advantage, which comes down to having the knowledge and the experience, which is why I guess you guys are all here, to be able to do so. So this alone will not tell you what is wrong with things in most cases. One of the 3 videos I've linked from this one is the amplifier repair, and if you saw that one, the powered mixer, you'll know that this told me where the fault was. A transistor was getting very hot. If you didn't watch, they'll tell you. This found me the transistor getting very hot. The transistor was not faulty, it tested fine. I then went around the circuitry nearby with a multimeter and found another transistor which had a very low resistance base collector. I replaced that one only to find it still didn't work, and the same transistor was still getting hot. But the one I'd replaced was no longer faulty, it didn't fail again. And then I spent another 30-40 minutes, an hour, tracing around, reverse engineering the circuit, until eventually I figured out there was a broken circuit track. So this gave me the clue, but this didn't tell me where the fault is. And I think you just need to keep that in mind if you're going to buy one of these, that it is a diagnostic tool. It's not a point, click, change this. Yeah? But having said that, I'm really impressed with this. I mean, It's an amazing bit of kit. I've never owned one and I've never used one. I've seen them on videos and thought, yeah, okay, I mean, nice. But it never occurred to me just how useful this thing is until I got one in my hand. And now I'm going to have to get one of these. I mean, I'm sure, although he didn't say, but I'm certain the guy who sent me this from Romania sent me this to help me to repair his motherboards and graphics cards, and I'm confident he'll want to have it back at the end of that work. But I've got to get myself one of these. Now, there's lots of models around. This one works fine. Would I buy this one personally? No. And the reason being, I'm making YouTube videos, and I know you can get ones that have a USB or mini HDMI output, and I can connect it to my PC, and I can see on the PC, which then means I can capture that and record that for you guys. But for most people, that isn't really a requirement. That's just a personal requirement. So I thoroughly recommend this, especially if the cheap retailer's got some at that price. Go and buy one when they've still got them. And I don't think you'll regret buying this or another thermal imaging camera. I'm impressed, guys. So I hope you enjoyed that one. I'd like to hear from you in the comments below. Have you used one before? If so, what are your thoughts on it? And if you haven't used one before, then would you use one now after you've seen this video? I'll leave you with that thought. I'm looking forward to your replies, and I'll see you all soon, guys, on another Learn Electronics Repair video. Ciao for now, guys.